Oh. So two functions are inverses if they are reflections of each other over the line y equals x. So we talked about inverses yesterday. So if a function passes the vertical line test, it's a function. If it passes the horizontal line test also, it's 1-to-1, and its inverse is also a function. What are you doing back? I don't know. So, did she fix you? Did she fix it? Okay. So we can verify inverses graphically and algebraically. So graphically, that means they're going to reflect over the line y equals x. Joseph, take out your earbuds. So first of all, no. First of all, let's graph the line. Okay. Are you arguing with me? I just want to clarify. I want to graph the line. So I'm going to start at -6. So it's a shift down of -6 and then a vertical stretch of 3. So I'm going to count up 1, 2, 3 and over 1. Use your handy dandy ID. It'll make a straight line. And then go ahead and put the line y equals x in. So now I'm going to find the inverse. So I switch the x and the y. So I'm going to add the 6 and divide by 3. So when I graph this, I'm going to start at 2. And I would go up 1 and over 3. Are you with me? So the lines are reflected. You can check the points are reflected across y equals x. Okay. If you fall asleep again, you have to stand in the back of the room. So sit all the way up. Okay. The next one. So first of all, I want to go ahead and graph this one. X to the third plus 4. So I'm going to start at 4. So shift up. X to the third looks like this. So over 1. Go ahead and draw in y equals x. And then we have to solve for the inverse. So I'm going to switch the x and the y. So what's the first step?
Bless you.
Bless you. So I'm going to subtract the 4. And now I have y to the third. And what's the inverse of the third? The cube root. So which shift do I start with? So it's the cube root, so it has to look like this. The minus 4 is a shift which way? To the right. 1, 2, 3, 4. So they reflect over the line y equals x.
How long did it take your son to become a lawyer?
3. You have to do undergraduate and then 3 years of grad. You did. You ruined my day, so now I'm just going to start talking. All right. So to verify algebraically, so this is how this works. So if the composition of both of them equal x, they're inverses. So if I do the first one, f of g of x, that means I'm going to put a parenthesis around g and plug it in for x. And if I do that, I get 2x plus 7 minus 7 over 2. What happens to the 7s? They cancel. What happens to the 2s? So what am I left with? So when I do it the other way, that means I'm going to put parentheses around the f, and I'm going to put it in for x. So this gets put in for the x. So I end up with 2 times x minus 7 over 2 plus 7. What? The 2's cancel, and then what happens to the 7's? And it equals, so these are inverses. So, what? No, my heart is hurt. But it's okay. Maybe when I'm done, thank you for offering. I might need some comfort then. All right. So x squared minus 5. Why is the domain restricted? It's a parabola. Does it pass the horizontal line test? No, it doesn't. So we have to restrict the domain. So if I graph this, I would have a shift down, and then I want the x greater than 0. So I only want this side of the parabola. And that passes the vertical and the horizontal line test. So I'm going to do f of g of x. So this is going to go in for my x. So what does the square do with the square root? They cancel, so that leaves me with x plus 5 minus 5. And these cancel, and it leaves me with x. So now let's do the other way. So this time I'm going to put parentheses and drop this in for x. So what happens with the plus 5 and minus 5? They cancel, and that leaves me with the square root of x squared, which is x. So these are inverses. So are we okay so far? Algebraically, they have to reflect across y equals x, and then, graphically they reflect across y equals x, and algebraically we do the composition. Okay, I'm going to do just these two examples and we'll be done. So first of all, go ahead and graph this. So to find the inverse when I switch the x and the y, then I'm going to subtract the 2. And how do I do the inverse of the cube root? Cubic, yes. Oh, it is wrong. Dang it.
I just erased it. So I was right.
No, I was wrong. I was graphing the inverse. Yes. When you asked me about it, and then I flipped it. This way. There we go. It's because my heart still hurts. Okay. So how do I undo the cube root? Cube it. So this is going to be my inverse. So what is the minus 2? Which way does that shift? To the right. And I don't go up and down any, so it's to the right. And now it's a cubic. Now it looks like what I started with. So those are inverses of each other. So then I have to find algebraically. We have to do the composition. So I want G, which is the one that I just found right here. I'm going to plug this back in for X right here. So I'm going to take the cube root So what does the cube root do to the cubic? They cancel, and it leaves me with x minus 2 plus 2, which is x. So then you have to do the other way. So this right here is going in for x. This whole thing is going in for x. So what happens to the plus and minus 2? They cancel, and the cube root is cubed, so this becomes x. So these are inverses. I graphed it. The original function. No. Okay, the one right under it is the last one I'm going to do. So go ahead and graph the beginning of this one. So what's being stopped? What am I doing here? It's a parabola. And why do I have x greater than or equal to -4? Why? I know it's restricted, but why? I know I said so, but why? It's graphing a parabola, right? So if I shift 4 to the left and down 2, and I make the parabola, does this pass the horizontal line test? No. But this says x is greater than or equal to -4, so it took this part of the parabola off. So now I'm only seeing this part, correct? So now it does pass the horizontal and vertical line test, and now we can find the inverse of it. All right? So when I graph this, if I start here, 1, 2, 3, 4, I go -4 and down 2. So I'm only going to have this side of the parabola. And then put in your y equals x line. And then let's find the inverse. I'm going to add the 2. Now what do I do? Square root. And subtract the 4. So when I graph this, then the +2 moves 2 to the left and down 4. So they are reflected across the line y equals x. So let's do f of g of x. So this is my inverse. So I'm going to take this and put it in for x. So this is going in for x. So when I do that, the -4 and +4, what happens with them? They cancel. So the square root is squared. So it becomes x plus 2 minus 2, which is x. So just one more check now. The g of f of x. So that means that I have to take this, and where I see the x here, I'm going to put this in here. So they will. But all of them I did are inverses. So the 2's cancel, and the square root of it means they cancel, so I get x plus 4 minus 4.